Today I'm going to teach you Kolbe reaction. Phenol is converted into salicylic acid in the presence of sodium hydroxide, carbon dioxide, and acidic workup. What we are going to add in phenol? We are going to add carboxylic acid group at ortho position. We are going to add COOH. That means for that we need one carbon, two oxygen, and one hydrogen. And for that we have reagents in this to get that. So the carbon dioxide is going to provide a COO, and for the H, for the proton, we are going to use acid. This is how, this is the source of this carboxylic acid group in this, and at ortho position we are going to add carboxylic acid. This is what salicylic acid is. Now the question is that why that carboxylic acid is going to add at particular ortho position. There are multiple position, meta is there, para is there. Since it is going with ortho only, why? The first of all, the thing is this phenol in which this hydroxyl group is orthopara director. That means meta is eliminated. And why OH is orthopara director, for that I will make a video later. And why this para is eliminated and the group is added at ortho position, that we'll see in mechanism. In the first step of mechanism, we have phenol and sodium hydroxide. Na plus OH minus. OH minus have a lone pair, so that OH is going to abstract a proton, hydrogen from OH, and will leave as water. H is gone, and now there is a formation of phenoxide. And now the sodium is going with this oxygen to form sodium phenoxide. That is the ionic bond between sodium and oxygen. Now in next step there is a carbon dioxide. Now the sodium is going to coordinate oxygen from this phenoxide and another oxygen from carbon dioxide to form this coordinate. Because of this coordination, ortho position favors. The proximity between ortho position and this coordination is very less, whereas the para is far away from this, and because of that this ortho position favors in this. So the carboxylic acid is going to add on the ortho position. Now look at the carbon in this carbon dioxide. It is highly electrophilic right now. Why? Because there are two highly electronegative atoms, two highly electronegative oxygen are connected with that, and because of that electrophilic right now, and this is electrophile right now. And this oxygen, which is going to form a double bond, because oxygen is electron rich and OH is electron donating group, so that O is going to donate the electron to the rings, and because of that now this carbon is being unstable with the 5 valency, so this adjacent carbon is going to accommodate this pi bond in the form of lone pair, and hence there is a formation of carbon anion. Now the carbon anion is a strong nucleophile, a hard nucleophile, and this is electrophile. So now this nucleophile is going to attack on this electrophilic carbon of carbon dioxide, and because of this coordination this ortho position is near to this carbon, so it can easily attack on that. That is why ortho favors. And now there is a bond is going to form between this carbon and this carbon. Carbon is being unstable with 5 valency, so this oxygen is going to accommodate that lone pair and will form oxyanion. So you can see that the carbon dioxide is added at this position right now. At the same time, this ring is now not aromatic. It has lost its aromaticity, and because of this intermediate is highly unstable. So it wants to be stable, and for that it needs to restore the aromaticity. And for that, this hydrogen from this site, this hydrogen is from this site, is going to abstracted by this electron rich oxygen and will grab that proton. So this hydrogen is transferred to this oxygen, and this carbon hydrogen bond is going to shift inside the ring system, and thus there is a restoration of aromaticity. So again this compound is going to achieve its stability. At the same time, this oxygen is being positive with 3 valency, and this carbon is with 5 valency, again highly unstable. And to stabilize that, this oxygen is going to accommodate this pi bond in the form of lone pair, and this bond is no more. So oxygen is stable as well as this carbon is stable as well. And in the final step, we are going to add acid, and acid have protons, and this oxygen is going to simply abstract that proton and will form OH, and this Na will live in the form of salt with that acid, and this is how there is a formation of salicylic acid. Thank you.